Welcome back to another video on AA learning. Today we're going to stick with integration rules, but instead of basic integration rules, we're going to go to trigonometric integration rules. So just before we get into this video, trig integration is this: you have to use the same process that you learn in regular integration, like u sub, any types of other substitution method or other methods of integration. You just have to use that, but incorporate it with like the trig functions you learn here. So this video is just gonna be like a basics of some trigs integration you guys should know. So yeah, let's start with some of the rules. So these rules you guys should have memorized either for like if you're in a high school class for calculus or introductory calculus class in college. You guys should definitely have these memorized. The first rule is the integral of sine x dx is equal to negative cosine x plus c. Okay. If you guys haven't watched my derivatives, introductory derivatives video, in the worksheet I provide some basic trig derivatives. You guys should definitely know that before starting your integration. It gives like a little bit of help for you guys. So if you guys did watch that video or go through the worksheet, you'd have seen that the derivative of sine x is equal to cosine x. And you can see here, if we took the integral of sine x, we're just adding a negative sign here. And there's going to be that plus c every time we integrate. Okay, the next rule is the integral of cosine x dx is equal to sine of x plus c. And if we go back to our derivatives, we can see the derivative of cosine x would be equal to negative sine x. We can see here it's like the negative's here, but when we took the integral, the negative is not there. It's kind of like these two inverse almost each other. But yeah, ignore the derivatives for now, just need to know the integrals. Alright, next would be the integral of tangent x, which is equal to negative natural log, and then always absolute values of cosine x plus c. And then there's also the integral of cotangent x dx equaling natural log absolute value of sine x plus c. What I like to remember here is that the tangent and cotangent, they're inverse of each other, and the tangent has a cosine in the middle, in between the absolute values, and then the integral of the cosine would be negative, which shows in the negative right here. And then it would just be the opposite for cotangent. Cotangent has that sign, and sign right here is positive, so that's why it's positive. That's how I like to remember it. You guys got a whole nother way, but yeah, if that helps, helps. The next integral would be the integral of secant x dx is equal to natural log of secant x plus tangent x plus c. And then the next one would be the integral of cosecant x dx is equal to negative natural log of cosecant x plus cotangent x plus c. Okay, I'm going to go back to derivatives because, again, it's important to know derivatives. Like, I like to think to know the integrals. It kind of helps. So if we go back, we know the derivative of secant x was equal to secant x tangent x multiplied together. And here, what do we see? We see the secant x right here, and we see the tangent x right here. And instead of multiplying, we're adding this time. And the same idea implies for the derivative of cosecant x, which gave us negative cosecant x cotangent x, which we can also see right here with the negative sign right there, and then the cosecant right there and cotangent right there. Again, they're just being added. Okay, the next rule would be integral of secant x tangent x dx is equal to secant x plus c. And then followed by that would be the integral of cosecant x cotangent x is equal to negative cosecant x plus c. Okay. Here, I like to just remember this one by the front has secant here, and then secant right here. And then for this one, same thing, cosecant here. Just remember cosecant, it's going to be negative. When there's cosecant here, there's a negative here. When there's, like any c, like this letter c we see right here, there's a negative. So that's how I always remember it, but yeah. See, there's a c right here, so negative, but yeah. Okay, the next rule would be the integral of secant squared x dx would equal tangent x plus c. And then the integral of cosecant squared x dx would equal negative cotangent x plus c. Okay, these rules you guys have to memorize again. So in the examples I'll give, we'll have to use some of these rules, and also we'll provide, as always, a worksheet to practice in the comments. Yeah. Okay, let's go to some examples now. Okay, so our first example is going to be the integral of sine of 3x dx. Okay, this is again like a more basic example, one of the more like easier ones you guys might see on like a test. So again, you have to use the rule of u substitution, which I went over briefly in the last video. I can make a more detailed video on that if you guys need. Okay, but basically for u substitution, we would let this inside value, so you would write it as let u equal to 3x, just to let our grader know, okay, we're substituting in the u for 3x. Now what you have to do is take the derivative of this u. So it would become du over dx is equal to 3. And now we want to isolate the du, so we would do du is equal to 3 dx. So what we can do here now is we can't multiply something so we can multiply something by 1, but we can't just multiply it by like a 3 and just let it be, because that's just like messing up the equation. But what we can do is adding this 1/3 in the front, multiplying this 1/3 in the front, so it becomes sine 1/3 integral of sine 3x 3 dx. That way, when you multiply this 3 and the 1/3, that's just multiplying the same thing as 1. So it like kind of cancels out almost. So when we can rewrite this again as 1/3 the integral of sine of u du. And now we can just use our integration rule that we know. So we have sine of u right here, and we know that from our rule that the integral of sine of x dx is equal to negative cosine x plus c. So we can simply just we know that the integral of sine of u would just be negative cosine of u. So the negative would come up front, so it'd be negative 1/3 cosine of u plus c. But we wouldn't be done because we know u, we let u equal 3x. So we gotta plug 3x back instead of u. So the final answer would actually be negative 1/3 cosine of 3x plus c. And that's our final answer for this question. Okay, let's move on to another example. Okay, so our next example is going to be the integral of tangent x times secant squared x dx. Okay, this one looks kind of complicated in the beginning, but it's actually really simple. So what I would do here is let u equal tangent of x. Now there's a reason I did that, because if we look back at this, we know that if we go back to my previous video on derivatives, in the worksheet I said that the derivative of tangent x, so we read this as du over dx, is actually equal to secant squared x. And why is this important? Well, we have a secant squared x right here too, so that makes our substitution even more easier. So we would isolate the du again, so it'd be du is equal to secant squared x dx. Well, we can already see we have the secant squared x dx term right here, and we let u equal tangent x, so this basically cancels out right here, so we can rewrite this as the integral of u du. Now that's easy, that's just to the power of 1. We can just use the power rule that we know, the power rule for integration that we know. And if you guys didn't know that, you guys should watch my integration video. And so what you just do is add here, so it becomes 1 plus 1, and then that's 2, so the 2 goes in the bottom here. So this is equal to u squared over 2 plus c. Now we can sub in the u, so it'd be tangent x squared over 2 plus c, and that would be a final answer for this problem. Okay, so those were some of the more basic trig rules that I would say but you guys may also encounter like inverse trig rules that you guys might see in like a quiz, a test, or maybe on the AP exam if you guys are taking it. And these are also important to know once you get to more like complex integrations, such as like PFD integration, which I can create a video if you guys need on that, as well as integration by parts, some of the more like calculus BC or calc 2 level concepts. So there's 3 main formulas that you guys should know for these. So the first formula for inverse trig integrations would be this: the integral of 1 over the square root of a squared minus x squared dx is equal to inverse sine of x over a plus c. Okay, that's the first rule. And I'll explain all the parts in some of the examples that I'll provide later. So the next rule you guys need to know is the integral of 1 over a squared plus x squared equaling 1 over a inverse tangent of x over a plus c. And the final of these would be the integral of 1 over x root x squared minus a squared dx. We should include the dx here for the integration, is equal to 1 over a inverse secant of the absolute value of x over a plus c. Okay, these are the integration for inverse trig that the formulas you guys should know. Okay, so before we get into it, we need to know that a will always represent some constant. So this could be like 3 or like 5 or whatever. And then the x in this case represents the variable, and whatever that variable may be. Okay, let's go through some examples. Okay, the first question is the integral of 1 over the square root of 9 minus x squared dx. Okay, which one would this most resemble? So from the equations I gave you guys, this one would most resemble the 1 over square root of a squared minus x squared, and that we remember is equal to inverse sine x over a plus c. Okay, so we basically just have to plug in wherever we have. So let's just label our x and a. I like to do this before just so we don't mess up. So our x would just be x in this case, and then our a would be 3. And the reason we do this is because we know a squared is equal to 9, so the square root of 9 is 3, plus or minus 3. But in this case, we'd use positive 3. So the answer, we would just fill it in. So inverse sine, arc sine of x over 3 plus c. And that's our final answer. It can be simple as that. Now, when you get to like, again, integration by parts or another weird integration rule, these are going to like sneak in. So you guys have to like make sure you guys are aware of where it is. So the last example I'm going to give for today is the integral of 1 over, actually let's do this in a new tab. Okay, so it's the integral of 1 over x squared plus 4. So going back to our formulas that I wrote down, this resembles the integral of 1 over a squared plus x squared, and that would be just like the 1 over a arctan of x over a plus c. So now we need to know that the a in this case is always going to be a constant, so it'd be 2, and then the x would just be x. Now we can just simply plug this in, so 1 over 2 arctan of x over 2 plus c. And that is our final answer. Okay, if you guys enjoyed this video, hit the like button, subscribe. Let me know if you guys want any other math, English, science, history, whatever topics that I can teach you guys. Yeah, thank you so much.